question on rivers. So nice easy one to start off with. We've got drawing a line to link each of the statements to the correct process. So hydraulic action is the force of the water. Abrasion is the load hitting the beds and banks. Attrition is when the load erodes itself by knocking into itself, and solution is dissolving it. So a nice straightforward one. You'll notice it was 3 marks, so if you got one wrong, you would get 3 marks, or if you got 2 wrong. Okay, so next one, we had a few problems with this one, but it's very clear in the question. It says draw a labelled cross section. Okay, so a cross section is a slice through the river. We've got to show the inside bend of a meander and how it's different. That's our focus, to the outside bend. So the first thing is, when we draw our meander, it must be asymmetrical. Okay, so not the same on either side. So the asymmetrical meander shape, it didn't matter which way around you did it, that was 1 mark. Okay, so the next thing is to show the differences. So we've got to have that it's shallow and that it's deep. Okay, we'll now show the features that we have on either side. This one can be called a slip-off slope, or you may have called it a river beach, either a fine, and on this side we have got the river cliff. Notice that my arrows are touching to the exact place that I'm talking about. If you don't do that, you don't get the marks. Okay, we might also put in here that the bank has been undercut. Okay, now we do not talk about any processes. We don't want to see anything about erosion or deposition. We're simply saying, how is this side different to this side? Okay, so 4 marks again. So level 1 to 2 was sort of disorganised, some mistakes, some confusion. Level 2, or if you did a plan form, so you looked at it from above. Okay, level 2, 3 to 4 was this. Okay, a nice definition question for question 3. What is a levee? Now notice it's 2 marks, so we've got to say 2 things. So lots of you drew some lovely diagrams of your levees on your nice floodplains, nice big flat floodplains, and there are your 2 levees. So we can describe a levee as a raised bank that runs alongside the channel. Excuse me. Okay, that's our 1 mark, so we've got to give another mark. Now, we're not going to say how it's made because that's explaining what it is, but we might say what it's made from. Okay, so it's made from sediment that has been deposited from by the river. So that's our 2 marks there. Right, our final question on this one, our 6 marker. Hard engineering is better at reducing the risk from flooding than soft engineering. Discuss this statement. Use evidence in your answer. So CFCs here. Okay, so our command word is a discuss. That means we can again use on one hand and on the other hand, but it's also really good to use some discussion words. So discussion words that show contrast or disagreement, and contrast, command word connectives that show agreement or emphasis, furthermore, and additionally are both good ones. Okay, so we know we've got to use evidence in our answer. So our content, we're definitely going to be talking about what happened at Banbury, the Banbury flood control. Now we need to look at our focus. So our focus is up here, and the focus is better. But what is better? Better at reducing the risk. We don't want to just say hard engineering is better than soft, or the other way around, but which is better at stopping people from being affected by the flooding. So I'm going to start with, on one hand, and I'm going to talk about hard engineering first, okay, and I'm going to give my example. So in Banbury, okay, we know that they built a flood embankment, okay, and that it was 3 kilometres long by 4 kilometres high. And why was that good? It reduced the flood risk to the M40, okay, which meant that businesses and people could still move around, so the economy didn't suffer and people could still go to work, go to school and so on. It also reduced the flood risk to 400 houses and 70 businesses. And one good example that you've probably driven past on the M40 is ProDrive, which makes all the tyres, and it was good to protect them, because together the cost of those flooding was about £20 million. So they've saved a cost. So this is very good at reducing the risk from flooding. So now we've got the M40 being protected and the homes being protected. So we have reduced the risk to businesses, people, and the cost of the flooding. Okay, so now on the other hand, okay, soft engineering was also good in Banbury. Okay, so what did they do in Banbury specifically? Well, specifically they designed a flood storage area, so that when it rained a lot, the water all went into this flood storage area, which was on the natural floodplain. So it worked with the river's natural way of working. Now this was good because it reduced the risk to Banbury, but, so we're bringing in our however here, a bit of complexity, it still allowed flooding to happen. So if you happened to be in that area, it might be that you were at risk from flooding. But in this natural floodplain, there were no houses built, and it had a huge capacity, so it was very likely to hold all the water. So this was really good. It was also really good because it provided new footpaths and green areas for people. So I haven't actually said which one I think is better. I've said that they're both really good, which is fine. Okay, so I don't have to agree or disagree. So at the beginning, I'm going to say I think both hard and soft engineering are equally good at reducing the flood risk. Now, it doesn't matter what you say here as long as your essay agrees with it.